Hello and welcome back. Back to linear algebra. I accidentally bought loose leaf version, not the textbook, so I have a binder, if you're wondering. What did we do yesterday? Well, we read about a lot of historical figures in linear algebra. We also read about a lot of applications of linear algebra, lots of scientific and engineering and computer science applications of linear algebra. What else did we do? Is that it? We started looking at the contents. But we also created an Anki flashcard in order to memorize the 9 chapters. Again, not knowing if this is worth it or not, but since we want to just really do this thoroughly, why not? Let's try it out. What are the 9 chapters in elementary linear algebra? So we got systems of linear equations, which we'll be getting into soon. Systems of linear equations and matrices. 2 is determinants. 3 is Euclidean vector spaces. 4 is general vector spaces. 5 is I don't know what 5 is. 6. Okay, I don't know. 6. Shoot. I don't remember. 6. Yes? Yes? No, yes, it's right there. Okay, 7. It wasn't dot products, it was like multiplication or something. No. 7, I don't know. 8, general linear transformations. 9, numerical systems. Numerical methods. General linear transformation. We said that, right? Eigenvalues and eigenvectors. Inner product spaces. Diagonalization, quadratic forms. Let's try it again. Linear systems of linear equations and matrices, determinants, Euclidean vector spaces, general vector spaces, eigenvalues and eigenvectors, something product spaces, linear product spaces maybe, diagonalization and quadratic forms, general linear transformations, numerical sequences, systems, methods, numerical methods. Was it linear product sequences? Inner product spaces. Everything else we got right, okay. Last time, here we go. Okay. In linear systems of linear equations and matrices, determinants, Euclidean vector spaces, general vector spaces, eigenvalues and eigenvectors, product spaces. Dang it, what was it? Product spaces. Not linear product spaces, something else product spaces. Dang it. Diagonalization and quadratic forms, general linear transformations. 8 is, or 9 I mean, is numerical methods. Product spaces, something product spaces. Inner product spaces. Damn it. Okay, here we go. Last one. This is it. Linear systems of linear equations and systems of linear equations and systems of linear equations and matrices. No, what the? Systems of linear equations? Systems of linear equations and matrices. Determinants, Euclidean vector spaces, general vector spaces, eigenvalues and eigenvectors, inner product spaces, diagonalization and quadratic forms, general linear transformations, and numerical methods. Okay, cool. Got it. All right. I said we're going to skip reading the table of contents because of what? Because of a study that would show that exposure to random lists did not increase any memory after being told to memorize the list. So we'll memorize potentially the sections in the chapter or within the chapter. So we'll ignore that for now. What is linear algebra about? What are the 9 chapters of linear? Okay, we got that one. Dedication page. About the authors, I'm just going to quickly just really read through this about the authors page and then recall anything I find important. Okay, nothing super relevant to me within that. Both of these authors, Anton and Call, seem very well established, respected, credentialed PhDs, doctors of mathematics. Dr. Anton has devoted a lot of time the past 40 something years to textbook writing, so this is probably a great piece of work. And next up we got the preface, which I'm gonna essentially scan unless there's important parts to my actual digestion of the book. All right, guys, so I read the intro section of the preface, the changes to this edition, and the section about the alternative version of the textbook. So starting with the introduction, this textbook looks to be highly praised and awarded, which is great because it is confirmation to my research that I did to choose this as a initial textbook to study linear algebra. They have a big focus on pedagogy, which I really appreciate. The goal of the book is to introduce linear algebra introduce it in the most the clearest way possible. Calculus is not a prerequisite, but there are some optional exercises that require calculus prerequisite or experience, which I have a little bit. Like I took Calc 1, 2, and 3, but it was high school. I didn't really study that much. So I might just skip those sections, maybe not, we'll see. There's also online exercises and stuff you can do with computer programs to practice potentially. So I may check that out as they come up. It's still kind of vague because I haven't got into actually what that means in the textbook, but that's pretty much all of that said. The new addition to the book, it doesn't matter. I don't think I'll spend any time really talking about that because it's not like I read the 11th edition or something, so not a big deal there. Maybe not worth the time to think about. And then the alternative text. So this textbook has a lot of applications, like application exercises to show how these concepts connect into the real world. But there is an alternative textbook that has a 10th chapter. There's only 9 chapters of the book. They have an additional chapter that has like 20 applications. So maybe I'll check out that textbook after completing this one. You know, it's annoying to get that kind of thing at the beginning, but I'm not going to let it stop me from getting through this textbook. Like I'm moving forward. I'm not going to sit and wait any longer. It's been weeks since I started self-studying math and I've been waiting for this textbook. I'm not going to wait another week to get another textbook. We're going to knock this out. Hopefully that one is the exact same. It just has the application text at the end. I think it probably is. So not a huge deal. Anything I'm forgetting? Cool. Got it all. And I'm going to continue reading the preface, and we'll quickly maybe be able to get through the preface today. Probably not, but hopefully by tomorrow we'll be into section 1, chapter 1, section 1, systems of linear equations and matrices. So I'll be back in a few seconds. All right, so this section was called Hallmark Features, kind of talking about their reasoning and their behind how they structure the text, and their pedagogical structure has five points. Let's see if I can recall them all. First, it's kind of to show the interrelatedness of all of linear algebra rather than it just being a collection of isolated definitions and concepts. They want to continually show how these are all related and draw connections between chapters. Secondly, they go to abstraction slowly and progressively. They were saying the transition from Euclidean vector spaces to general vector spaces is troubling. That abstraction can be difficult for some students. So they try to make it very, methodical and structured towards abstraction and help you abstract successfully. 3, it's the textbook is made for a diverse background audience, whether you're STEM major or like a biology major, a psychology major, computer science, engineering, whatever, or even a math major. It's work for all for them. They try to be as mathematically precise as possible with still being accessible to beginners. So I think that means something along the lines of proofs being built in slowly rather than just throwing all the mathematical precision and proofs quickly. And then there's a 5th thing. I'm not sure. Historical notes. So they think it's important to have some historical background, how these ideas and the people that came up with them came to be and why they were created, and give some historical context. I really like that idea. Okay. So about the exercises, how much time we got? I'm gonna read this last section for today, and then we'll recall it, and then we'll call it a day. And tomorrow, based on how much we moved through today, we should be able to get to the first section tomorrow, which will be nice. So I'll be back in a sec. All right, guys, wrapping up for today. This last section was about the exercises in the book at the end of each section. So the sections are kind of grouped into different types of 3 different types of exercises, I believe. 1 is working with proofs, 2 is true and false, and then 3 is technology work. So on the true and false, on the proof, so they're kind of like linear algebra differs how it's taught with how much focus is on proofs. This one has a lot of focus on proof. So proofs are going to be in, there's an appendix on proofs. So we'll have to read that tomorrow because I've never worked with proofs. I think I was just about to study them in discrete mathematics. It's like logical proofs, right? Yeah, we learned a little bit about proofs. It's deductive reasoning, but we will to read that Appendix A, which is just 4 pages. We'll check that out. That will have to take some work, actually. We'll have to go through that slowly because that's going to be important. And on the true and false, to avoid guesswork, you've got to justify your reasoning in some way and why you chose true or false. That's to check conceptual understanding. Working with technology, they have a website with the documents and stuff, do the technology problems. And then at the end of each chapter, there is a section about questions that use a mixture of all the sections from that chapter at the end of each chapter. So that's it for today. Linear algebra, we're getting closer. I would say tomorrow and the next couple days, potentially we'll be reading Appendix A. Then we'll come back, finish the preface, and then we'll be into chapter 1. What is Appendix B about, though? Complex numbers. I wonder if we'll have to or should read this. I don't really want to. I'd rather just get into it, but if we have to, maybe I'll have to ask ChatGPT if I should read Appendix B. I'll take a note of that. Cool. All right, guys. I will talk to you later. See ya.